Correlation and regression. Welcome to GER Hub from all over the world. Wherever you're watching from, please smash a like on the video. We are about to begin. I'm happy to see you. I hope your day was good. Thank you for joining in on the class. If you haven't subscribed to the channel, please endeavor to subscribe to the channel. And please endeavor to help us tell colleagues of yours in the same department offering this course, Intro to Statistics, taking correlation as a topic, correlation and regression as a topic, who do not understand correlation and regression as a topic, tell them to join in this class. We've been having a good time on GER Hub with our lessons on correlation and regression for some time. In today's video, little break in transmission. So sorry about that. I had to do some settings, so sorry about that. Please, let us now begin quickly. So welcome to GER Hub Mathematics and Statistics lessons. In today's video, we shall be rounding up our discussion on introduction to correlation and regression. Okay, so what did we do in our last class? In our last class, what we did was to look at regressing one variable on the other and regressing the other variable on the first one. Okay, so if you had variable x and variable y in the bivariate data, what we did in the last class was to regress x on y and y on x, and I told you that we could use such. That implies that we could use such to model situations involving x and y, in which case x can be taken to be the dependent variable and y the independent variable. And when you regress y on x, it means y is dependent variable and x is the independent variable. So in today's class, what we shall be discussing will be where we shall be rounding up our discussion on correlation and regression. Thank you for the likes. Thank you so much. So let's begin. Please pay attention and we shall get there. Good. So we shall be looking at two things in today's class. We shall be looking at product moment correlation coefficient, and that is objective number one. We shall be looking at deriving and using the product moment correlation coefficient. And two, we shall be looking at getting using the Spearman rank correlation coefficient. Okay, Spearman rank correlation coefficient. Good. Now let's now start this video with discussing what these two measures are. So what is the product moment correlation coefficient and what is the Spearman rank correlation coefficient? I'm going to start with the product moment correlation coefficient. Now, the product moment correlation coefficient is also known as Pearson's correlation coefficient. Okay, so let's begin our discussion from that point. So if you don't want to call it product moment correlation coefficient, then you could call it Pearson's correlation coefficient. Okay, so then for Spearman correlation coefficient, if you don't want to call it Spearman correlation coefficient, you can just call it rank correlation coefficient for short. Now, these two correlation coefficients, if you must know, are measures of correlation. They help to tell the strength of correlation between two variables in a bivariate data. So let's assume we know that x and y are two variables describing a bivariate data. Now, if there are two variables describing a bivariate data and they are so related, maybe you chose to model x on y or y on x. The question is, like we earlier said, Good evening, blessing you. Welcome to the class. I really appreciate your attendance and presence. Thank you. Please just listen as the video goes. So, what are we doing? If you are just joining in from any part of the world, what is today's live class all about? We are discussing two major things: product moment correlation coefficient and Spearman correlation coefficient. Now, I have just said that these two are measures that help you determine the strength or weakness of correlation correlation between x and y for a bivariate data. So if two variables are so related, the question is, what is the strength of the relationship? Is it weak? Is it strong? How strong is the strength between or the strength of the relationship between the two variables? How weak is the strength of the relationship between the two variables? So that is what correlation coefficients do for you. Now, we are going to be discussing two types of correlation coefficients: the product moment correlation coefficient, also known as Pearson's correlation coefficient, and the Spearman correlation coefficient, otherwise called rank correlation coefficient. Now take note, one of them is parametric and the other one is non-parametric. So which one is parametric? Take note, product moment correlation coefficient is parametric and Spearman rank correlation coefficient is non-parametric. Okay, so that is what I want you to know, and let us begin. So the question we are going to be starting with is, what is product moment correlation coefficient? How does the formula look like? So let's begin from that point. Now, I'm going to take you back to what we have done previously. You would remember this. That in our class, our last class, if you didn't watch or did not attend that class, please go to the link in the description below after this class to watch the video all over again. It will give you an idea on what we are saying in today's class. So, what are we doing in today's class? We are looking at two correlation coefficients: Spearman rank correlation coefficient and Pearson's correlation coefficient, also known as product moment correlation coefficient. Now, we are starting with product moment correlation coefficient. So what do we want to do with this? We want to derive it and also use it. And I'm saying how to derive the product moment correlation coefficient comes from, okay? So if there are two variables, x and y. Now, regressing y on x gave us the model this: y equals ax plus b. So in this case, we were regressing y on x. What was y in this case? When you regress y on x, y becomes the dependent variable, okay? And x acts as the independent variable. So again, I'll repeat that. When you regress y on x, what happens? When regressing y on x, it makes y the dependent variable and x the independent variable. But when you regress x on y, it makes x the dependent variable, okay? It makes x the dependent variable, and in this case you have a prime y plus b prime. And in this case, what does y become? It becomes the independent variable. So, in the last class, I showed you this. So if you were not in that class, please go over the video again to understand what we did in that class. So our objective in the last class was to model y in terms of x and to model x in terms of y. And the language, statistical language, when you do so, is regressing y on x. When you regress y on x, it means you would have an equation like this. What did we call this equation in the last class? We called it the regression model of y in terms of x. What did we call the regression model in this case? We called it the regression model of x in terms of y. Because in this case, we were regressing x on y. But in this case, we were regressing y on x. Now, the implication of regressing y on x means that you are making y the dependent variable and x the independent variable. The implication of regressing x on y means that you are making x the dependent variable and y the independent variable. Now, another thing we said in that class, still continuing from this, was the next thing. So, what did we get? What did we get? When you regress y on x, so I'm going to write here, when y is regressed on x, y equals ax plus b. Now, what was your a? A will be equal to, from what we established, you can go over it again in that video. We established that a will be equal to n summation I equals 1 to n of x, y minus summation, so that is summation x, summation x, summation y from I equals 1 to n, all over n summation x squared minus summation x from I equals 1 to n, in this case, all squared. So, this is what you will get when you regress y, when y is regressed on x. This will be the formula for getting your a, the coefficient of x. Now, when you regress, that is when x is regressed on y. Good evening, Ayan Samson. Welcome to the class. When x is regressed on y, just join in. I'm going to repeat myself very soon. When x is regressed on y, what will you get your a to be? Your a, or in this case, a prime. Remember, when x is regressed on y, we have this, that x is equal to a prime y plus b prime. Now, what is your a prime? Your a prime will be equal to n summation from I equals 1 to n xy minus summation x from I equals 1 to n summation y from I equals 1 to n all over n. This time around, it will be y, no more x. So this will be y squared from I equals 1 to n minus, in brackets, summation from I equals 1 to n y all squared. So this is what you will get. Again, let's go over the story for those of us just joining in. Please, I have to repeat this. It is very important. Your interest, or my interest rather, is in your understanding. So once again, welcome. I'm going to be very fast with this, so please pay attention. Those of you watching right now, I can see 4 people and I am seeing 4 likes. Thank you very much. So in today's class, everybody, we are rounding up correlation and regression. And I'm saying that today's class is all about discussing correlation coefficients. And I'm taking 2 types of correlation coefficients in this class. What are they? Correlation coefficient 1 is product moment correlation coefficient. Correlation coefficient 2 is Spearman rank correlation coefficient. Now, I started with saying that product moment correlation coefficient, being a type of correlation coefficient, has another name. You can alternatively call product moment correlation coefficient Pearson's correlation coefficient. Now, Spearman correlation coefficient can just be called for short rank correlation coefficient. So that was where I began the class. Okay, so next, I now took us to what we had done previously. Where did we stop in our last class? In our last class, our focus was on showing that for a bivariate data involving 2 variables, say x and y, it is possible to regress x on y, and it is also possible to regress y on x. Now, what were the implications? In that class, I explained this, that when you regress y on x, what it means when somebody tells you that kindly regress y on x or regress a variable a on a variable b, what it means in this case for y and x is that when you regress y on x, automatically y becomes your dependent variable and x acts as your independent variable. These two values here, a and b, are concrete values. They are constants, so they are actual values, but these are variables. Y and x are variables. So y is the dependent variable, x is the independent variable. A and b are constants called parameters. So what do we call a and b? We call both of them parameters of the regression model. Parameters of the regression model. Okay? The same thing happens when you regress x on y. When you regress x on y, it makes x your dependent variable and y your independent variable. But because when regressing y on x, the constants, the parameters you would have are not the same as the parameters you will have when you regress x on y, we are using a prime and b prime to show that the parameters will not be the same. So they still remain parameters, but they won't be the same. So we call them again parameters of this particular model involving you regressing x on y. Now, this was the focus of the last class on correlation and regression. If you were not in that class, please, if you did not follow that video, go and watch that video. It is titled Correlation and Regression Part 1, Episode 4. Now, after discussing this, in that particular class, I showed you how to obtain A and B, how to obtain the parameters of the model for y regressed on x, and how to obtain the parameters of the model for x regressed on y. So the question in that class was, what will be your A when you regress y on x, and what will be your B? I showed it in that video. What will be your A prime when you regress x on y, and what will be your B prime when you regress x on y? These were the things we discussed in that video, and thereafter we solved examples. Okay, so go over that video again and watch what we did. You will find it very, very interesting. We solved concrete examples to show how to obtain A, B, A prime, and B prime. Now, I showed you also in that video, I told you something in that video. You must take this very, very important, that when you regress y on x or regress x on y, when you are asked a question regarding regressing y on x or x on y, please take note. They want you at the end of the day to obtain something that looks like this: y equals 5x plus 6. Meaning that when they ask you to model the relationship between y and x, they want exact values for a and b. When they ask you to regress x on y, they want to know exact values of a prime and b prime. So regressing x on y or regressing y on x involves obtaining the parameters of the model and putting same into the model to get the actual model. So this is just a general regression model involving y and x. When you put the values of a and b, it becomes a specific model. Okay, so those were the things we discussed in the last class. Moving on, I now went on in today's class to start talking about what we are to do. So what are we to do now that we know that we are going to be discussing two types of correlation coefficients, namely product movement correlation coefficient and Spearman rank correlation coefficient? What are we to do? First of all, we are to look at product movement correlation coefficient, and apart from explaining what it is, we want to obtain a formula with which we obtain correlation coefficients from product moment. Okay, so I am saying, for you to understand how the formula was derived, you must take note of what was done in the last class. Now, if you regress y on a, your regress y on x, we remember that we obtained our a to be this. This is what we obtained our a to be. We obtained our a to be this when we regressed y on x. Now, what happened when we regressed x on y? We obtained our a prime in that model to be this. Now, the question is, now that you know how to obtain your a when y is regressed on x, and now that you also know how to obtain your a prime when x is regressed on y, how then do we get the product moment correlation coefficient? That is the question. And I'm going to now tell you this. Whether you are referring to product moment correlation coefficient, or you are referring to rank correlation coefficient, or any other type of correlation coefficient, please, statistically, you must take note. R, small letter r or lowercase letter r, is used conventionally, we use small letter r or lowercase letter r to represent correlation coefficients. Okay? So we often use small letter r to represent sample correlation coefficients. Now, how do we now obtain the correlation coefficient called the product moment correlation coefficient? And I'm going to show you this. So, product moment correlation coefficient is obtained when you take the square root of A times A prime. So, if we call this small letter r, if small letter r represents product moment correlation coefficient, I am telling you in today's class that to obtain product moment correlation coefficient, all you need to do is to take the square root of the product of A and A prime. So, remember what A is. This is what A is. So, A is given as this, and A prime is given as this. So, you look at it again. So, what am I going to do? I want to obtain the formula for product moment correlation coefficient. So, since I know it is the square root of A and A prime, I'm going to simply do this. R will be equal to the square root of A, starting with A. So what is our A? Our A is N summation from I equals 1 to N xy minus summation from I equals 1 to N x summation from I equals 1 to N y, all over N summation from I equals 1 to N x squared minus summation in bracket from I equals 1 to N x all squared. So I'm going to put this in bracket. Everything here is A. Remember, product moment correlation coefficient is obtained by taking the square root of A times A prime. So now this is for A. I'm now going to put in the expression for A prime. So what is A prime? So A prime now would be you taking this N from I equals 1 to N x y minus summation from I equals 1 to N x summation from I equals 1 to N y. Close the bracket, all over N summation from I equals 1 to N y all squared minus summation from I equals 1 to N y all squared. Okay, so this is the product of A and A prime under the square root. Next, we will simplify to get the actual formula. So I'm going to put this here. I'm going to bring it so that you see what is going on. So the next step will be the simplification process. So I'm going to come over here and say R is equal to square root of, I'm going to merge this now, and you will notice that this and these are the same. So I'm going to merge them and do this xy minus summation from I equals 1 to N x summation from I equals 1 to N y close bracket all squared, all over in one bracket N summation from I equals 1 to N x squared minus summation from I equals 1 to N x all squared, close that bracket, open another bracket, N summation from I equals 1 to N y squared minus summation from I equals 1 to N y all squared. And I'm going to close this bracket. Now, you will notice this. Now, what we have is the square of 110. Okay? Now, if you simplify further, the square of the square root will give us the number itself. So I'm going to bring this one. Since we have all these squared, when you take the square root, you have one of it. Okay? So I'm going to bring out this result. And this will now be N summation from I equals 1 to N xy minus summation from I equals 1 to Nx summation from I equals 1 to N y all over this. And that is the square root of this times the square root of this. I'm decomposing the square root now. The square root of this times this is the same thing as the square root of this times the square root of this. So this will give you what we call the product moment correlation coefficient. Okay, this will give you the formula for the product moment correlation coefficient, and I'm going to be using it immediately to solve a problem. So guys, this is what we have. So what do we call this formula? We call this formula the product moment correlation coefficient, and that is how it is derived. Again, let's go over what we did. I told you that whether you are talking about rank correlation coefficient or you are talking about product moment correlation coefficient, all correlation coefficients statistically are conventional. Conventionally means by agreement. In most cases, R signifies or represents correlation coefficient. So if we are talking about product moment correlation coefficient, it won't be out of place to use R to denote product moment correlation coefficient. Now the question here is, how do we obtain the formula for product moment correlation coefficient? The idea is to take the square root of A times A prime. And what is A? A was obtained earlier to be this. Okay, this was our A from the previous video, and this was our A prime from the previous video. How do you get your A? A is the coefficient of X when Y is regressed on X. How do you get your A prime? A prime is the coefficient of Y when X is regressed on Y. So now this is the formula for A and this is the formula for A prime. So what are we saying? If you want to obtain the product moment correlation coefficient, all you have to do is to take the square root of the product of A and A prime. So what I did was to write R equals the square root of whatsoever A is times the square root of whatsoever A prime is. And that gave me this. But I didn't stop there. I now went on to doing the next step. So from this step here comes this next step, where I now merged. Now you will notice that from this step, what you have in the numerator times what you have in the numerator here are the same. So it's just like saying A times itself. A times itself will give you A squared. So this times this in the numerator will give you one single thing, all squared. Now the denominator has two different terms. So I'm putting the two different terms in a bracket, in two separate brackets. But this one, merging them under square. Now, when you take the square of the square root, or you take the square root of the squares of a number, let's say 5 squared, the square root of 5 squared will be 5. The square root of 9 squared will be 9. The square root of 16 squared will be 16. So when you take the square root of the square of a number, you will get the number. So the square root of this in bracket all squared will return that same thing. And that was how I got this, being my numerator. But the square root of this in product is the same thing as the square root of the first term times the square root of the second term. And I'm saying that this formula is called the product moment correlation coefficient. Now guys, let us use the product moment correlation coefficient to solve a simple problem. Okay, let us use it to solve a simple problem very, very quickly. Okay, so what are we going to do now? Let me show you a simple problem that we can solve. Okay, so let's start with this. Assuming you were asked to solve this, you were asked to find the correlation coefficient between a variable x and a variable y, and this was given to you. So you were given this x and y. 1, 2, 3, 4, 5, 6. Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9, and then 10. Okay, and you were given the values 6, 8, 4, 7, 3, 5, 9, 10, 6, and 1 under x. Let's take values on under y. Let's say we have 5, 6, 3. Let's say we have 5 and 3. Let's say we also have 2, 7, then 8, 4, and then 2. Now, if you add all these under x, how to solve the problem will begin with you finding the totals for x and y. So if you are given a problem like this to find the correlation coefficient between x and y, all you have to do is draw out your table, getting the totals of x and the totals of y. Why am I getting the totals of x? In this formula, note that there is a total for x, there is a total for y, so we have to obtain it. And there is a total for the product of x and y. So you will come over here to start with and add everything under x. Let's add 6 plus 8 is 14. 14 plus 4 will give you 20. 20 plus 7 will give you 27. 27 plus 3 will give you 30. 30 plus 5 will give you 35. 35 plus 9 will give you 44. 44 plus 10 will give you 54. 54 plus 6 will give you 54 plus, okay, let's go over it again. Sorry. 6 plus 8 will give you 14. 14 plus 4 will give you 18. 18 plus 7 will give you 25. 25 plus 3 will give you 28. 28 plus 5 will give you 33. 33 plus 9 will give you 42. 42 plus 10 will give you 52. And 52 plus 6 will give you 58. 58 plus 1 will give you 59. I think that is correct, okay? That should be correct. So summation x, we are going to write is equal to 59. Now, if you add 5 to 6, you will get 11. 11 plus 3 will give you 14. 14 plus 5 will give you 19. 19 plus 3 will give you 22. 22 plus 2 will give you 24. 24 plus 7 will give you 31. 31 plus 8 will give you 39. 39 plus 4 will give you 43. And 43 plus 2 will give you 45. So I think that should be the result. So this will be 45. Now that we've obtained the summation of x and the summation of y, let us now put in other columns we need. So we are going to put in extra columns, okay? So let's put in what we need here. Let's put in what we need. I'm going to expand this. So you do this if you are writing an exam or you're answering questions such as this. So I'm going to put here, next I'm going to put x squared. So what is x squared? 6 squared will be 36. 8 squared will be 64. 4 squared is 16. 7 squared is 49. 3 squared will give us 9. 5 squared will give us 25. 9 squared will give us 81. 10 squared will give us 100. 6 squared will give us 36. And 1 squared will give us 1. Okay? So let's go over to y squared. Y squared, on the other hand, will give us 5 squared is 25. 6 squared is 36. 3 squared is 9. 5 squared is 25. 3 squared is 9 again. 2 squared is 4. 7 squared is 49. 8 squared is 64. 4 squared is 16. 2 squared is 4. Okay? So if you take the total for y squared, if you add the totals for y squared, 25 plus 36 plus 9 plus 25 up to the end, let's add, okay? You would end up getting 241. You end up getting 241. And if you take the totals for x squared, you would end up getting, so you verify that, you end up getting summation x squared will give you 417. Now, what have we done? We have obtained x squared and y squared and the totals thereof. Now, the next thing we are going to do will be to obtain x times y. So, obtain x times y. I won't be needing this, so I'm going to cancel this off. So, obtain x times y. Under x times y, all you have to do is to multiply this. 6 times 5 will give you 30. 8 times 6 will give you 48. 4 times 3 will give you 12. 7 times 5 will give you 35. 3 times 3 will give you 9. 5 times 2 will give you 10. 9 times 7 will give you 63. Okay? 10 times 8 will give you 80. 6 times 4 will give you 24. 1 times 2 will give you 2. And that will give us summation xy to be equal to, summation xy will give us 313. Okay? Now, once you obtain the totals, you quickly go to the formula. Now, you go to the formula. I'm going to bring the formula here and keep the totals just by the side. So, go to the formula. What does the formula say? R will be equal to the square root of, what is your n? Your n is the number of data entries, and we have 10 of them. So I'm going to put here 10. Okay, so this is our formula. I'm going to put in brackets I'm going to put here 10. Okay? Let me bring a cleaner sheet. Let me bring out a cleaner sheet. Okay? So let me do this. Better. Okay? So this is better. Now, so the formula would now be R equals n summation from I equals 1 to n x y minus summation x summation y from I equals 1 to n I equals 1 to n all over square root times square root again of n summation x squared from I equals 1 to n minus summation x all squared from I equals 1 to n. And here you have summation from I equals 1 to n y squared minus summation in bracket from I equals 1 to n y all squared. Now, this is the formula. So, look at our summation. For under x, we had n, which is in this case 10. I'm going to write 10. What is your summation xy? Summation xy was 313. So I'm going to put here 313. Okay? Minus, you come over to the next one. What was your summation x? It was 59. I'm going to put 59 here in bracket. What was your summation x? I'm going to summation y. I'm going to put here 45. You will see this is 45. All over square root of n, which is 10 times summation x squared. Summation x squared is 417. So I'm going to put 417 here. Minus, what is summation x all squared? It will be 59 all squared. Then I'm going to come to the next square root and put here 10, which is this. Okay, so this is 10. Now, what we obtain summation y squared to be 241. So I'm going to put 241 here. Minus, I'm going to put the next thing, which is summation y all squared. So summation y, we got it to be 45. So this will be 45 all squared. Okay, so the next thing after this is simplification. So if you simplify, you are going to end up having 3,130, sorry, minus, if you multiply 59 by 45, you are going to have 2,655. Then below here, you are going to have 4,170 minus 59 squared should be 3,481. Okay? Then in this other square root, you would have 10 times 241 gives you 2,410 minus 45 all squared will give you 2025. Okay? Now, R will end up becoming 475 when you subtract 2,655 from 3,130. When you subtract that, you are going to have this as your numerator. And this will give you, when you subtract this from this, you end up having 689 times. When you subtract 2,025 from 2,410, you are going to have 385. Okay? So, if you simplify and divide, your result will be approximately 0.9223. Okay? So, this is the result you are going to get as your correlation coefficient. Now, before we proceed, now that we have our value of R to be this, the question is, what does it mean? So when you obtain the correlation coefficient between two variables, it actually means something. And that brings me, before we move on to rank correlation coefficient, I must talk about the properties of correlation coefficients. So the question is, what are the properties of correlation coefficients? So let's quickly discuss that. Properties of correlation coefficients. It is very, very important because it is not just getting your correlation coefficient as a value. You must know what that value means. Remember, we talked about correlation as a measure, a statistical measure of the strength or weakness of a relationship. Now that you've gotten your value to be 0.9223, it means something. And I want us to explain what the properties of correlation means and with that you will know what that result. We will go back to that result so that you can actually draw your inference or conclusion based on the properties we've discussed. So property number 1. Okay, now that we know that R represents correlation coefficient, so what does property number 1 say? The value of R is the same irrespective of which of the two sets of data we label X and Y. That is property number 1. So what that means is this: whether you choose X as your dependent variable or Y as your independent variable, the value of R remains the same. That is what it means. So irrespective of what variable is chosen to be dependent or independent, the value of R, the correlation coefficient, remains the same. Okay? So somebody may ask the question, will your R value change if you choose X as your dependent variable and Y as your independent variable? Will it change if you choose Y as your dependent variable and your X as your independent variable? The answer is a big no. Whether Y is chosen to be your dependent variable or X is chosen to be your dependent variable, the value of R remains the same. Okay? So that is property number 1. Property number 2, guys, is that whenever you get your R value, take note, how do you know that what you have solved is correct? The R value, as a rule, must never go beyond this boundary. Meaning that whatever the value of R you obtain from your result, it must lie between -1 and 1. So you cannot obtain an R value that is greater than 1, neither can you obtain an R value that is lesser than -1. If you obtain such results, you are wrong. You have to check your solution process again. So R in property number 2 must lie between -1 and 1. And you will notice something about our result. 0.9223 lies between -1 and 1, showing you that what we have solved is correct. Now, property number 3. Let's go to property number 3. Okay? Now, the closer your R value is to these extreme values, tells you the strength or the weakness of the relationship. Okay? It tells you whether the relationship is positive or the relationship is negative. So you must take note of that also. So if R is very, very close to 1, as R tends to 1, what does it mean? As R tends to -1, what does it mean? If R is tending to 1, then the relationship is positive. We say the correlation is positive between X and Y. If R is tending to -1, we say the correlation is negative. Okay? So when R is closer to 1, we say the correlation is positive. That is, if it is tending towards 1, we say it is positive. Now, an R value that is greater than, an R value that is very close to 1, say 0.9, 0.8, those kind of R values are strongly positive. But an R value that is closer to 0 is said to be, good evening, Uka, welcome to the class. Thank you very much. I'm expecting your reply in my email. I want to believe you've sent it there. I'll check it immediately after this class. Thank you very much. So the closer your value to 1 and the closer your value to -1 tells whether it is negative, your result, or positive, your result. And you must take note of that. Now, based on these properties, if you want to conclude on the relationship between X and Y, judging by this result, we say statistically that the correlation between between X and Y, judging by R giving us 0.9223, we say that the relationship between X and Y, is strong and positive. Why is it strong? It is because the value 0.9223 is going so close to 1. Okay, so it is very, very strong because it is close to 1 And because it is close to 1 also and not a negative value, we say it is positive. If we had our result to be minus 0.9, we would say it is negative. But in this case, it is close to 1, so it is strong. It is very close to 1. 0.9 is very, very close to 1, so it is very strong. The relationship is very strong. And not only is it very strong, because the value we got is positive, we say it is strong and positive. So what if we got a value such as 0.2? 0.2 will be a weak but positive value. The closer your result is to 0, tells you how weak it is. So if we got a value as such as 0.3 or 0.2, after getting the correlation between x and y, we would say the relationship is weak but positive. But because it is very close to 1, we will say it is strong but positive. If the result was closer to minus 1, we would say it is strong but negative. But if it was far away from minus 1 and less than 0, we will say it is weak but it is weak and negative. So I want you to understand those properties. Having said that, please go over the video again when we are done with the live class, just in case you don't understand. And if there's any question you have, please feel free to ask now. Okay? The last thing I want to discuss in this particular video is the rank correlation coefficient. So the rank correlation coefficient is an alternative, just in case you do not like to use, you don't want to use the product moment correlation coefficient. There is another type of correlation coefficient you can use, and it is called the Spearman rank correlation coefficient, or just the Spearman correlation coefficient. So what is the formula for the Spearman rank correlation coefficient? So let's put it here: Spearman correlation coefficient. So what is the formula for Spearman correlation coefficient? The formula is R equals 1 minus 6 summation d squared all over n minus 1, n squared minus 1. This formula is the formula for obtaining the Spearman rank correlation coefficient. Now, some of you may ask, sir, why use the Spearman rank correlation coefficient? I'm going to give you a quick reason. Now, the Spearman rank correlation coefficient does not need you to know the values of x and y. It does not use the values of x and y in getting the correlation coefficient. Rather, it uses what we call the ranks. It uses the ranks of the values to get the correlation coefficient, so it does not use the values themselves. Rather, it uses their ranks. So let us take a quick problem using this and round up this video. So I'm going to show you quickly how we rank. So I'm taking 10 values, okay? 1, 2, 6, 7, 8, 9, and 10. I'm taking 10 values. So let's assume the values given to you are 53, 38, 61, 86, 28, 76, 50, 90, 37, 49 for x. And let's assume y values to be 48. Okay? Let's assume y values to be 48, 36, 67, 47, 53, 80, okay? 80, 45, 83, and then let's say 52 and 60. Now, the question is, how do you use the formula, this formula for obtaining the correlation coefficient? What you would do is to get the ranks of x and y. So you quickly come over here, create another column for the problem, and then put here Rx. Okay? Rx means rank of x, or the rank of x values. So you put here Ry. Ry means the rank of the y values. So the question is, how do we rank? Okay? By convention, the ranking is done in this manner. The smallest value, if you start, for example, you have 10 data entries for x, 10 data entries for y. So you have 10 data entries. The largest value is 10. Okay? In the ranking system, the largest value will be 10. You would give this from Or among all the values under x, you give the smallest number the highest rank of 10. Okay, that is the biggest value, 10. And you give the greatest number the smallest value, 1. Okay, so let's do that. If you do that, you will notice that what is our biggest value? Our biggest value is 90. So we are going to put 90 as 1. Our next value to 90 is 86. So we are going to give it a rank 2. The next value to 86, let's check. If you check among this value to 82, should be 76. So we are going to give 76 3. The next value to 76, let's check. After 76, what's the next value? That should be 61. So we are going to give 61 4. The next value to 61, if you look among the values, should be 53. So we are going to give 53 5. The next value to 53 should be 50. So we are going to give 56. Okay? The next value to 50, let's see, is 49. So we are going to give 49 7. The next value to 49 is 38. So we are going to give 38 8. The next value to 38 is 37. So we are going to give this 9. And the last one, the smallest value 28, we are going to give 10. Now, once you are done ranking, again, remember, the first thing you must know about the Spearman rank correlation coefficient is that, okay, welcome, excellence. After the class, you just go over the video, okay? We are trying to round up. Welcome. Sorry you came in late, but just go over the video. When we are done from beginning to the end, you will understand what we did. We are just continuing from the last class, and we are wrapping up our discussion on correlation. So this video ends our discussion on correlation and regression intro. Okay, so let us now come over here and rank the values under y. Remember, the smallest value will get the largest rank. The largest value will get the smallest value as rank. Okay, so what is the largest value here? The largest value here should be 80. Let's see, is there any value? Okay, 83. So 83, we are going to give 1 to 83 because it is the largest value. Next to 83 is 80, so we are going to give 82. Next to 80 is which value? Is what value rather? Next to 80 should be 67, if I'm right. So 67, we are going to give 3. Next to 67 is what value? We have 53. Okay, 3. Let's see. Next to 67 is okay. We have 60, so I'm going to give this 4. Next to that should be 53, so I'm going to give 53 5. Next to 53 is what value? 52. So we are going to give 52 6. Next to 52 is 47. So we are 48. We are going to give this 7. Next to 48 is 47. We are going to give this 8. Next to this 47 is 45. So we are going to give 45 9. And next to 45 is the last one. We are going to give this 10. So 36 is the smallest value. We'll give it 10. Now, once you are done doing this, you will come over and then obtain your D. This D in the formula. Okay? This D in the formula is equal to the rank of X minus the rank of Y. Okay? So we are going to obtain the D value. So you come over here and obtain your D values. So what are your D values? D values, X minus Y. 5 minus 3 will give 5 minus 7 will give you minus 2. 8 minus 10 will give you minus 2. 4 minus 3 will give you 1. 2 minus 8 will give you minus 6. 10 minus 5 will give you 5. 3 minus 2 will give you 1. 6 minus 9 will give you minus 3. 1 minus 1 will give you 0. 9 minus 6 will give you 3. 7 minus 4 will give you 5. Okay? 7 minus 4 will give you 3, sorry. So you are going to now, once you are done doing this, you will now square your D values. So when you square your D values, minus 2 squared is minus 2 times minus 2, so that will give you 4. Minus 2 squared will give you 4 again. 1 squared will give you 1. Minus 6 squared will give you 36. 5 squared will give you 25. 1 squared will give you 1. Minus 3 squared will give you 9, positive 9. 0 squared, we'll just put 0 there. 3 squared will give you 9, and 3 squared will give you 9. So once you are done, you would add up all these values under D squared, because in your formula there is a D summation D squared. So you add up all these values. 4 plus 4 plus 1 plus 36 plus 25 plus 1 plus 9 plus 9 and plus 9, I think should give you 98. So our summation D squared is 98. Okay, now once you are done getting this value, you will come over here and do this. So r again is equal to 1 minus 6 summation d squared from I equals 1 to, in this case, 10, all over n squared minus 1. So you can actually use small n in this case because we are talking about a sample of values. So what would you have here? 1 minus 6 times summation d squared. Remember, we got our summation d squared to be 98. Okay, so this will be n is 10, so this will be 10 squared minus 1. Okay, finally, what would your result be? 1 minus 6 times 98. 6 times 98 will give you 588. Now 10 squared is 100. 100 minus 1 is 99. 99 times 10 will give you 990. So you have 990. Now 1 minus 588 divided by 990. Let's punch. Okay, so 588 divided by 990 will give you approximately 0.5939. And when you subtract, you end up getting the result as 0.4061. So 0.4061 will be your result for R. Now, what would you conclude based on what the properties of correlation coefficient? Based on the properties of correlation coefficient, we will conclude that R is positive but weak. Why is it positive but weak? Remember, one property of R says that R must always lie between -1 and 1. Another property of 1 says that the closer R is to 1, if R is very close to 1, it means it is very strong. The relationship between X and Y is very strong. If R is very close to -1, it means the relationship is also very strong. But the difference between these two strengths we are talking about is that when R is very close to 1, positive 1, we say it is positive and strong. When R is very close to -1, we say it is negative but strong. But what you must know is this: if R is very close to 0, we say it is positive but weak. If R is very close to 0 from the negative axis, we say it is negative but weak. Okay, so R can be positive and strong, R can be negative and strong. R can be positive but weak, R can be positive and negative but weak. So please go over the video again, watch what we have done so far. I don't see questions coming from all of you. If you have a question, quickly ask that. We are about to go into the maths class on theory of quadratic equations, where I shall be solving problems we had solved previously. Please go over the video, smash a like on the video, and drop your comments. Whether now or after now, I'm going to reply your comments. I will read through your comments and I'll reply them. Solve the problem all over again and tell me what you've discovered. Thank you very much for watching this video, and God bless you. Let's see you right now in the mathematics class on theory of quadratic equations. Thank you.